All right, today we're starting our next area of study, which is the conic, polar, and parametric functions, is what I've called it. You can call it other graphs or something like that. But there are other ways that we can do some of the things that we already know about. We already work with the Cartesian system, and this is another way of working with things, particularly parametric and polar, in terms of graphing. And the conic, we're still using the Cartesian system, but it's another way of looking at certain things that we already know about. All right, so before we get on to those things, we're looking at today at what's called reciprocal functions. So it says here in mathematics, the term reciprocal means 1 over something. So if I've got the reciprocal of A, the reciprocal of A means 1 over A. So of course we can do that with functions as well. So if we, so we can do that with functions as well. I thought I'd put some more stuff there, but I haven't. All right, so we can do it with functions as well. All right, so we can do this with functions. All right, so fx, for example. So the reciprocal function, as we would call it, the reciprocal function reciprocal function is, well, reciprocal means 1 over, so it's 1 over fx. Now, we have an interesting thing that occurs. Depends on how you view the world, I suppose. But now that we've got 1 over, because we know, as we know, 1 on 0 is undefined. Is undefined. Then that gives us a interesting thing if fx equals 0. Thus, when fx equals, thus when f of x equals 0, the reciprocal one on fx is undefined. All right, and so what does that mean? Well, in terms of our graph, it means on a graph, this represents, or this will be represented as an asymptote. All right, so reciprocal functions 1 over, and then if where our function, our original function, is equal to 0, then our reciprocal functions can have asymptotes. And so the example that I've got here is, say, x cubed. So sketch the reciprocal function, which is y equals 1 on x cubed. It says here a graph of fx can be helpful. All right, so if here's our x and y axes, and then the graph of x cubed would go like this. All right, so what we can see here from this particular thing is that x cubed is equal to 0 here. In this case, at the origin. All right, so we can see a few things. So the first thing that we can see is f of 0 is equal to 0. So what that means is 1 on x cubed has asymptote at x equals 0. All right, so that's the first thing that we can see. Secondly, and I'm going to use some mathematical way of writing these things down. So if we look up this end here, what happens here is x gets bigger. So as x gets bigger, so as x goes towards infinity, what happens with fx? Well, fx, as we go bigger this way, we go bigger than this x. So fx, that also gets bigger. So what does that mean for 1 on fx? Well, if 1 on fx goes towards 1 on infinity, which is 1 on a big number, which goes towards 0. Now, I'm going to put a little plus here because it goes towards 0, but it's a positive number, right? These are positive y's. So towards the 0 from the positive side. All right. And I'll get to graphing that and explain a little bit more what all that means in a minute when I sketch the graph. But so what we've done is we've identified that there's an asymptote here because the y value is 0, or if fx is 0. We've identified as we go up this way that our reciprocal function is getting smaller as x gets bigger. What about down the other way? So as x goes towards negative infinity, then what happens? Well, fx gets bigger, but it gets bigger in the negative direction, so it goes towards negative infinity. What does that mean about 1 on fx? Well, that means that 1 on fx is going to go towards 1 on negative infinity. And again, 1 on a big number is a little number, but this time the little number's a little negative number, so it's going towards 0. And then I've got here with a minus, and that's from the negative side. All right, so let's see, how do we draw that? I'm going to draw that on here so that we can keep. Oh no, I won't. I'll do it here. All right, so this was x cubed. All right, and what I'm going to do down here is the reciprocal, so 1 on x cubed. All right, so we know from there we've got an asymptote at x equals 0. So we've got an asymptote here. And so what do we know? So we know as x goes towards infinity, then it goes towards 0. So when we get up here, we're going down towards 0. From the positive side. So as x gets bigger, y gets smaller towards 0. Over here, as x gets bigger in the negative direction, it goes towards 0 again, but from the negative side. So down here, so I want to talk about from the negative side. So it gets smaller towards 0 from the negative side. And so this graph I've now got is 1 on x cubed. Now this x-axis, see how it's going towards 0, that is also a asymptote as well. All right, so that's what that particular graph would look like. So we use that kind of analysis when we're looking at what our reciprocal graphs might look like. So often our original function is useful to have before we do our reciprocal, if for no other reason to find out where our asymptotes will be, because our asymptotes will correspond to wherever that x-intercept is. All right, so what have we got for the next one? So here's another one here. Consider the function fx equals x squared minus 4 and sketch the graph of y equals fx and the reciprocal as well. Alrighty, let's then go and have a look at what fx. So if fx is x squared minus 4 and y-intercepts will be where x equals 0, and so f of 0 is 0 squared minus 4, so y-intercept at minus 4. X-intercepts, y equals 0, so 0 equals x squared minus 4. Alright, so what we can do is we can go, okay, well that's adopts. So 0 equals x plus 2, x minus 2. And then, of course, if that is correct, null factor law says that x is going to be negative 2 or 2. And turning point for this, well, symmetry tells us the turning point's halfway through. So the turning point is halfway between x-intercepts, which of course that means x equals 0. And seems we've already figured out that over here. So we've got a turning point at 0, negative 4. All right, so let's sketch that graph. And once I've sketched that graph, we'll have a look at the reciprocal. All right, so if we've got 2 here, we've got minus 2 here. Well, let's get rid of that. And we've got minus 4 here. And so we know that our graph we're looking at goes around like this. All right, so that's our original. Fx equals x squared minus 4. All right, so the next thing that we're going to do is we're now going to draw one on f of x, which is 1 on x squared take 4. All right, so as we've mentioned before, when fx is equal to 0, which occurs here and here, net 2 and negative 2, then the bottom here is going to be 0, it's going to be undefined. So we have some vertical asymptotes. X equals minus 2, and x equals 2. So here we go. What's going on there? What I've done there. All right, let's do that. Here's my asymptotes. All right, so that one's x equals 2. This one's x equals minus 2. All right, what happens? All right, let's look what happens as x is getting bigger up here. So as x goes towards infinity, then fx, which is here, infinity squared, take 4. So fx goes towards infinity, and it's positive. And so 1 on fx then goes towards 0 because that's getting and from the positive side. So we've got goes like this. As x goes to negative infinity, then fx negative infinity, so x squared. So if we square a negative number, we get a positive, and then we take 4 away from a massive number, it's going to still be positive. So it goes towards positive infinity. And so 1 on fx goes towards 0, but again from the positive side over here. All right, now in the middle, right in the middle here, we've got a value. So when x equals 0, we know that fx, or f of 0, is minus 4. So 1 on negative 4 is what 1 on f of x is. All right, so we've got an intersection here, and the coordinates of that are 0 and negative 1/4. So now we've got to kind of think about what's going on. Now, let's have a think. And this is some kind of funky math stuff here. So as x goes towards 2 from the positive side, so as x goes towards 2 from the positive side, when we square it, we've got a number bigger than 4, yes? And so a number bigger than 4, take 4 is a positive number. So this is actually going like so. However, from the negative side here, so a number we're going here towards there, it's a negative number, when we square it's positive, but because it's less than 2, it's going to be less than 4. So say, for example, I took 1. 1 squared is 1, take 4 is negative 3, so it's down here somewhere. So what's going to happen is this is going to curve around like so. And then if we use the same sort of analysis over here, we'll find that this one goes like so, and this one goes like that. All right, so if you're a little bit confused and not sure about, this sort of stuff as x goes to infinity, as x goes towards 2 and stuff like that, make sure you get some help understanding what that's all on about. So anyway, the reciprocal function is this orange one, and that's 1 on x squared take 4. All right, the next sort of reciprocal graphs we're going to look at is reciprocal circular functions. All right, so I've just got these drawn. So sec, of course, is 1 on cos, and cos goes like this one, and that's this. That blue one is cos. All right, so if we're looking at the same kind of thinking, then when cos is 0, which is at pi on 2 and 3 pi on 2, we've got to have asymptotes. All right, so same as before. When cos is 1, 1 over 1 is 1, so it's there. When cos gets littler, so less than 1, say a half, you've got 1 over a half, which 1 over half is 2. So what you see happening is that curving up like so. Again, here 1 over -1 is -1, and curve around there like so and like so. So they're heading towards our asymptotes, and then as cos gets little, 1 over a little number is a big number. And over here, 1 over 1, and there's the other part. So that orange one that I've done then is the sec graph. All right, we can look at similar thing for a sine. So sine starts here, goes like so. There's our one cycle of our sine x. And using the same sort of analysis, 1 over 0, wherever the y value is 0, is where we get our asymptotes. Here when sine is 1, 1 divided by 1 is 1, then a similar shape to the 1 over cos, and here at 3 pi on 2, 1 over -1 is -1, and then of course curving around like so. All right, so again we'll use our standard sine, our standard cos, standard sine, our standard cos, to work out what our reciprocal circular functions. So reciprocal circular functions, sec, cosec, there is also cot as well, but we're not going to look at cot, we're just going to look at sec and cosec. So let's have a look at an example. So let fx equal to cos x for 0 is less than or equal to x is less than or equal to 2 pi. And we're asked to sketch both graphs. We're asked to sketch the graph of y equals fx and y equals 1 on fx. Okay, so if fx is cos 2x, so from that our period is 2 pi on n, and n is 1, so it's 2 pi. Our amplitude, so how high it goes, is 2. All right, so let's draw our graph. So we're asked to do it between 0 and 2 pi. All right, and amplitude is 2, so we're up here at 2. And we go down to -2. All right, so normally cos starts at 1, but because we've got an amplitude of 2, it starts here. Then 1 does its wiggles, and then 1 period later it gets back to the same spot, and 1 period is 2 pi. So over here we're back up to the same spot. Now halfway in cos graphs, halfway between our maximums is where our minimum is, and that's down here at -2. And then of course halfway between our mix and is where we cross our axes. Oh, I haven't put that one in a very good spot, have I? I'll put it halfway. Yes. So that's our pi on 2. That's our 3 pi on 2. And so we've got a graph that goes like so. Oh, that's a bit icky. Let's get rid of that. No, that's not too good either, but anyway, that's the best I'm going to be able to do, I'm afraid. All right, so there is our fx. So y equals fx is this one. Now we're asked to draw the reciprocal as well. And so let's draw the reciprocal as well. So key things, when fx is, so this is in the orange, so fx, when fx is equal to 0, which is here and here, is where we have asymptotes. All right. Now, here, this time fx is when x is 0, fx is 2. So when x equals 0, fx is equal to 2. So that means that 1 on fx is equal to a half. So rather than as in the previous one, when I just looked at the straight sec and cosec, we've now got 1 over 2, which is a half. So we've got that down here. And then, of course, it's going to curve up like so. Similarly here at pi, fx is negative 2. So when x is equal to pi, fx is negative 2. So that means that 1 on fx is going to be 1 on negative 2, so negative a half, so down here. And then it's going to curve around like so, and like so. And here at 2 pi, well, it's just going to be, because it's 1 period later, and then, of course, it's going to curve around that way. All right, so using our function, and we do a rough sketch of that, rough graph of that, and then we use that to pick out some key features of our reciprocal, and then we draw it. All right, so something a little bit different. Of course, if you need assistance with any of that, make sure you do get some help. And as always, have fun.